Okay, to measure the voltage and current through a filament bulb at different supply voltages, you'll need a filament bulb. You'll need a power pack. These are the power packs we use. You can see the positive terminal for the positive lead and the negative terminal for the negative lead. This is how we change the voltage. 9, 7.5, 6, 4.5, and 3. This is how you turn it off and on. So right now it's on, there's off, and it's connected to the main supply. Alright, so we're going to leave that off for now because we're not using it, and we're going to put it just there. We're going to need a voltmeter, an ammeter, and we are going to need some leads. So when we are building our circuit, we need to connect a negative lead to the negative terminal, positive lead to the positive terminal. Now remember, these are just wires and they do the same thing, they're just different colors. So it doesn't matter if we swap these the other way around, they do the same thing. Okay, but to make it easier to visualize, we're going to connect the positive to the positive and the negative to the negative, even though they do the same thing. We're going to put our ammeter into the circuit. Remember, ammeters are connected in series, positive to positive. We're going to need another negative lead, like so, and we need to bring in our filament bulb. We're going to be using this circuit board. We can plug in this to here, and now as you can see we have one pathway for the current to flow. So if I turn this on at 3 volts, and I turn the ammeter on, you can see we have a current that's a positive. Okay, you might not be able to see the bulb light up because it's quite dim, but it is lit up. The last thing we need to add to the circuit is our voltmeter. Now voltmeters, you can't connect them in series, you can only connect them in parallel. So we're going to put that here, and we're going to connect it in parallel. This is often referred to as piggybacking, because it's piggybacking onto the circuit. So we'll connect this in parallel. Turn this on. I'm going to swap these around so we have a positive number. Like that. Okay, and as you can see, we now have a voltage of 3.22 and a current of 0.1 amps. So 3.2 volts, 0.1 amps. And all we need to do to change the supply voltage is go over to our power pack and change it from 3 to the next number, which is 4.5. So we just want to change it to 4.5. And as you can see, the voltage has gone up to 4.46 and the current has also gone up to 0.13. If we go to our next voltage of 6, you can see that the bulb is getting brighter. Next voltage is 6.3 and our current is 0.15 amps. Keep going to 9. You can see we have a voltage of 8.88 and a current of 0.19. The last one, 12, you can see how bright the light bulb is now. We have a voltage of 11.9 and a current of 0.22 amps. Now, if we wanted to have a supplied voltage of minus 3 volts, we can turn the power back down to 3. So it was at 12, now it's at 3. All we need to do is change the polarity of the circuit. So we want these numbers to be negative now. We just need to change the direction of the current. How do we do that? It's very simple. We just change the leads around. So the positive into the negative and the negative into the positive. And as you can see now, at minus 3 volts, our voltage is now minus 3.17, and our current is now minus 0.11. Move on to the next voltage. At 4.5, our voltage is minus 4.5, current minus 0.13. At 6, the voltage is minus 6.34, and the current is minus 0.16. At 9, the voltage is minus 8.9, and the current is minus 0.19. And at minus 12 volts, the voltage across the bulb, otherwise known as the potential difference, is minus 11.87, and the current is minus 0.22. Okay, and always remember to turn off your circuit when you're not using it to save energy.